Thanks, Carolina. I appreciate it. Thanks for having me here. This will be a presentation on larvicide applications using unmanned aircraft systems to help battle some of these floodwater species we've been hearing about today. As Carolina mentioned, my name is Scott Schon. I'm one of the lead VCTs at Placer County, as well as one of the district's UAS operators. So we're all familiar here with traditional larval inspection in some of these floodwater areas, finding the water, walking out with a dipper, and taking your sample. This was one area of our operation we wanted to see if we could integrate any kind of drone technology in. And back in 2016, 2017, we got our first waterproof drone. This drone was able to fly over to water, land in it, and it has a 4K camera that would sit below the water line, and we would try to pick up larvae. It did provide some phenomenal underwater videos for some sources that had very little vegetation. However, there were some challenges as well. Being able to land that drone into these pond surfaces and having it drop below your visual line of sight was a risk. And then with the drone just drifting across the surface of the water, it was easy for it to turn into a really fancy weed eater. So although there are some source types where it is appropriate in, and as the technology improves, it may get better as time goes on. But for now, don't get rid of those dippers quite yet. And the traditional mosquito control, just like other mosquito districts you've heard today, the using of Argos, quads, or treating on foot. This was a niche that we thought the drone would be good at and provide us another tool to help kind of bridge that gap between treatments on foot or quad and manned aircraft treatments. So a couple of years ago, we got our first spray drone. This is a DJI Agras MG1S. It has a 2.64 gallon tank on it. It has 8 motors. It's compatible with 4 T-jet nozzles. We've been using the extended range fan nozzles with our aircraft, but you can also use some of the hollow cone T-jets as well. And it has 2 variable speed pumps on it. Each pump will control a pair of nozzles in the front and back of the aircraft. The transmitter or the remote you see on the bottom right has a built-in screen. This is the interface that a technician would use to put in all the flight parameters needed to make that spray block. I like to go over our specific model of aircraft because when I start talking about performance of the spray system, all that, just keep in mind that that's for this aircraft specifically. With more of these going on the market now, you're starting to see some with booms on them. Some are octocopters and some are quadcopters. And all these configurations will have different impacts on air assist and the way the spray system works. Before we can start treating, there is some regulatory things you have to go through. I won't go into too much detail, but number 1 and 2 here is the civil route. So anybody can go and take a test from the FAA. It's called your Part 107, and that would certify you to fly drones that were under 55 pounds. If you get that with your Part 137 certificate, which would be assigned to your district or your government or your agency rather, then you could do aerial applications. Just keep in mind there's certain exemptions you'd have to apply for because the 137 certificate was originally written for manned aircraft. There are going to be some things that just won't apply to drone applications. Your other option, if you're a government agency, is to register your drone as a public aircraft, and then you can fly under what's called a COA or Certificate of Authorization. And just keep in mind each state is going to have their local regulations as well. Here in California, we have to take a test with California DPR, and then register our aircraft and pilots with the Ag Commissioner each year. So first things was calibration. It has a built-in flow rate calibration built into the software for this aircraft. Pretty simple process. You just put in a known amount of liquid in the tank and you'll calibrate each pump at a time on the ground. Typically, you're going to do this if you're replacing pumps or had to replace the nozzles. Next step for us was really to start evaluating the spray system and see what we could get out of it. Those of you that are familiar with manned aircraft, this is a similar trial where you'd lay out chromocope cards or water sensitive cards, and you'd fly your aircraft through the center of those cards. And then you could start looking at the droplet spectrum, look at the size of your drops compared with the density, and really see what the system is doing for you. The other option of that is to add cups to these stations. So here's a picture of one of our trials this past season. And the cups is really just checking the efficacy of the dosage. So we could do bioassays back at the lab when we were done and start looking at droplet data compared with mortality data. This is a quick little clip. This is a kind of another version of that trial. So instead of having one pass, you set up a line 120 feet long, and then you can do multiple passes. And what this is telling the technician or operators, if we have our swath set wide enough, making sure that there's no valleys in the data that's graphed, that we're getting good coverage across that spray block. This is just an example. We use image J for scanning our cards. These solid lines are top, correspond with these numbers on the left. That's your droplet size. Typically, we look at DV5 or your DV50, and all that's telling you is 50% of your droplets are that size or smaller. Little dotted lines correspond to drop numbers on the right, and that's droplet density. So here we're looking at how many drops are per squared centimeter. And the numbers along the bottom, that's just all the stations that have the cards and cups at them. Really, the biggest thing to take away here is when we're looking at droplet size, just remember DV5 or DV50 has to do with droplet size. Here's a picture of one of our bioassays after the trial. Again, we're just checking that the efficacy of the dosage that we're applying. We add water to these cups, and we'll add mosquito larvae, and then we'll do mortality rates 24 hours after introducing those larvae. So these are some of the parameters that we've kind of determined just doing some of these trials here. Typically at an application height, we're looking at 10 to 12 feet above ground level. Our swath can vary anywhere between 18 and 32 feet, mainly dependent on that application height. Speed, we're anywhere between 7 to 11 miles per hour. And nozzle type, again, we're using the T-Jet extended range fan nozzles. Application rate could vary depending on product. Most of our work to this date has been with 12 AS or liquid BTI. We've been applying that at about 16 ounces an acre. We do dilute it with water, so we're putting out an application rate anywhere between a half a gallon to a gallon an acre for some of these sources. And these are some of the sources that we've been doing some of our drone treatments over the past year or two. Pastures, wetlands, snowmelt, sloughs. Now I'll go into a little bit more details with some of these source types. Irrigated pastures is one we've heard about today. This is probably the most optimal source type for a liquid application, mainly because the vegetation canopy is not too tall, so it's not obstructing any of that material to get down into the water column. Very few hazards as far as trees that would be in our flight block. I got a short little clip of the treatment of this, using those same parameters as I previously mentioned, around 10 feet high, around 10 miles per hour. You see most of the water was at the lower end of this pasture, but most of it was actually in the tail ditch going back. All around, it was about 4 acres in size. I always get asked, how long does it take you? Obviously, there's a lot of variables to that question, but under those flight conditions, we treated it in about 16 minutes. That's actual flight time. So if you had to make a spray block doing that, it would take more time. Another source type we use UAS applications would be some of our wetland areas. This is a little private duck club we have in our county, and if the whole thing's flooded like you see in this picture, typically we would just hit this with our manned aircraft. However, there are times that we're done with manned aircraft operations, or maybe they've only flooded 1 or 2 ponds. In that case, we will use a drone to do treatments on these sources. Unlike that pasture that we just saw, typically along these pond edges, we got a lot more vegetation, a lot more trees. And we are limited on our application height, especially using liquid. Obviously, the higher you go, drift becomes more of a concern. So the drone, you do have to map out that spray block around all those obstacles. And the picture that you see here is the flight path of the video you just watched. And the drone was flying along this white path going in and out of these trees. Sometimes the obstacles may not be along the pond edge. It could be out here in the middle. If you look at this yellow portion of this spray block, this was an island where the trees were up above our application height. So although the software does allow you to map out these obstacles, you're still just not going to get as good of coverage around those water lines as you would if you could fly all the way over it. Ideally, this would probably be a great spot for our granular application. Instead of trying to make our spray block in and out of these hazards, I would make the spray block go right over the side of this pond and fly over the tops of those trees. This is another slough type area in our county. Typically when the water's in its banks, it's full of mosquito fish and we don't have any issues. However, during rice season, when all the farmers start releasing water out of the rice fields, some of these sloughs will swell up, overflow their banks, and create a mosquito habitat. Similar to that irrigated pasture, the drone was a great tool for us for these type of treatments, very little hazards in the flight area, and just the sheer size of the source made drones a good fit for this. Typically, we're seeing about 10 to 12 minutes of flight time with these drones where we're treating. And obviously that can change depending on the elevation we're flying at or the weather we're flying at. But generally speaking, 10 to 12 minutes. There, the drone will pause like you saw it in the video. We'll fly back to the home location. And there we can top off the material and swap batteries while we're there. It takes us about a minute to swap it out. So no, it's not too bad. Once it's all topped off, you click continue, that drone will be able to fly back to that breakpoint that it created and continue treating. Most of all of our treatments really so far have all been fully autonomous. So all the work's done on the front end of making the spray block, getting the drone where you want to go, and then kicking back or watching the drone, making sure everything's operating the way it's supposed to. Snowmelt areas. So our county goes all the way up to Lake Tahoe. This is a picture of Squaw Valley, home of the Winter Olympics back in the 60s. And this is a 150 acre meadow that we have. And when the snow melt starts melting, it'll create all these pools like you see in the picture on your bottom right. And really just the sheer size of this made a drone a good tool to try to get some treatments in. Accessibility, it's hard. We're not gonna be driving our Argos or four-wheelers through this environmental sensitive area. And traditionally, all of our treating methods for this have been on foot. So a couple of guys with Mariyamas or solos walking to treat this. So we were happy this past season to get our first drone treatment in. However, we did come across some challenges here too. Mainly, we're in the middle of a forest, so there's plenty of trees and hazards, as well as just tall grass and vegetation. Some of the grass here was 2 to 3 feet tall. You really couldn't even see the water underneath it. So although we didn't have the best results that we wanted with our liquid applications, we are excited to come back out here this following spring and try with the granular formulations. So kind of the future of UAS, we've done a lot of work on those protocols and evaluating the drones at different heights and different speeds. And we've done a few different types of pesticide, and we have a few more liquid formulations, including WDG we would like to try through the system. But then we'll put that granular spreader on, mainly for the reasons I've already mentioned in this presentation, but also opens the door up if you want to do any kind of pre-treatment or do a treatment with more residual. Next picture you can see a few drones flying together. Drone swarming is becoming more popular, seeing a lot of light shows and stuff now. We have met with some companies that offer that. You do need a waiver because it is against current regulations. And it kind of is a way to cut into that 10 to 12 minute flight time, right? Now you could have 3 to 5 drones out there flying. However, now that's 3 to 5 drones that you need to keep within line of sight. So that may have some of its own challenges as well. The picture on the bottom right is a fully electric unmanned airplane. This is from Pika. If you haven't heard of them, give them a look. Pretty interesting company. This aircraft has a 600-pound payload. It flies around 90 miles an hour. The wings pop off of it and you transport it in the back of a trailer. So all you need is a 150-foot dirt road and it can take off and land and everything's completely autonomous on it. They kind of just tell as time goes on and technology gets better, I see drones being a more valuable tool in some of the work that we do and controlling some of these floodwater mosquitoes. With that, I'd just like to thank Ev and Brian and Mike. They're in operations here. They've helped with the trials, and Jen and Tommy and the rest of the staff at PNVCD. Appreciate all your work. Doing these trials and doing bioassays, it's a lot of cups and a lot goes into it. So just want to appreciate that. And that's my name and email on the bottom. If you have any questions and you'd like to reach out to me, feel free and I can help you out where I can. With that, that's all I have, Carolina.
Thank you, Scott. We do have questions and we have a few minutes, so I'm just gonna read them for you. Would you please remind the audience what program you used for scan your cards when doing droplet analysis?
Yeah, it's called ImageJ. It's one of the free softwares. I believe it's a USDA software. If you want, you can get my email. I can try to send out more information. It was the one that we already had set up with our district. I know there's a few others that you can pay for as well.
Okay, great. Thank you. Another question, Scott. When using a drone, what kind of adjustments do you have to make for wind speed?
Yeah, good question. Yeah, that's all things we're still trying to figure out. Just in the last year of doing treatments, if I had wind that was higher than 6 or 7 miles per hour, I'd probably be a little nervous doing a liquid application. But just applying some common sense to it too. You know, if you fly in lower and slower, it seems like we have least likely for the product to drift off target. So that's one of the things with doing those trials we're really trying to figure out is I'd like to have different application heights and different speeds for different scenarios and sources. I think you're muted. I couldn't hear your question.
Sorry, I clicked. Last question for you. Are you using DJI Terra for your mapping or just drawing your sites?
Yeah, so far we haven't used it. Those aren't familiar. DJI Terra is kind of like a smaller drone you could use and scout out and make your spray blocks. I heard of some mosquito districts that have used it. I haven't really heard of how well it works. One of the problems with making those spray blocks is you're either using the remote as a GPS or you're flying your drone around the perimeter. And to try to get close to some of these trees or obstacles, you want to get as close as you can to provide good coverage, but you don't want to get close enough where you're going to hit any of these obstructions. So to answer the question, as of now, no, we're making all these by foot, but that's something in the future we would love to look at.
Okay, great. We still have time for one more question. Here we go. What size of land area does one load of granules on those drones cover?
How much does it cover? Well, it's going to depend on your rate. So for ours doing liquid, we got 2.5 gallon tank, and if we're applying at a gallon acre, we're just shy of those 2.5 gallon or 2.5 acres rather. Obviously that will change if you're going out to a 0.5 gallon an acre, then you're going to get close to double that. One of the major differences that just hearing other districts talk and what we've seen a little bit of is with liquid, you're not seeing as large of a swath as some of these other aircraft or platforms are seeing using a granular formulations. I've heard of some swaths with granular formulations going all the way out to 80 feet wide, where typically we're looking to still at that 18 to maybe 30 feet. So it will vary.